Hello all. So let's see a project. So this is a IoT based smart home project which is based on this TF Robots Fermion BLE sensor module. So main hardware of this project is TF Robots Fermion BLE Sensor Beacon module. So we have utilized this module to build this project. We have seen detailed information review about this module in our last article and video, how to configure this module and all the features, specifications, documentation, etc. So you can check that out. So let me give you a brief information about this module. So this module is nothing but a BLE sensor beacon. It has an onboard SoC, system on chip, that is IN100. So this chip has a features of, it has an onboard built-in 11-bit ADC. It has a capability of Bluetooth low energy. We can interface analog digital sensors to it, and also it has a one wire I2C and UART capability. So via UART you can program or configure this module. You can connect I2C and analog digital sensors to this module. This module collect all data, environmental parameters and sensor parameters, whichever you connect or interface with this module, and then it will broadcast over BLE as per you provided configuration. So this module is nothing but a wireless sensor data collection node. You can use it for. So in this project, which is a smart home, we have used four different beacons, four different BLE sensor data collection nodes. These BLE beacons you can see here. So I will show you all assembly and all the sensors one by one. So let me show you first sensor. So this is an analog ambient light sensor. So we have connected this sensor to this BLE sensor beacon module. Then next sensor is SHT40 I2C sensor, temperature and humidity sensor. You can see this sensor here. We have interfaced this to another BLE beacon module. Then next is analog soil moisture sensor. So you can see this is TF Robots analog soil moisture sensor, which we have interfaced with another BLE sensor beacon module. And then last one is the sensor, that is analog smoke or gas sensor. So you can see this sensor, which is interfaced with another BLE sensor beacon module. So there are four modules, sensor beacons in this project. So these all modules or sensor beacons broadcast all the sensor data like the temperature, humidity, ambient light, soil moisture and gas. All this data broadcast it via BLE around it. So we have used this IoT hub main controller, in which we have used this Fire Beetle to ESP32E microcontroller development board. So because this board has a capability of Bluetooth LE BLE reception, also it has a dual mode Bluetooth and Wi-Fi capability, so we can also connect it to Wi-Fi and internet. So we also interfaced one buzzer module for notifications, and as it is a smart home application, we have also connected one relay board to connect different appliances like a heater, cooler, fan, air conditioner or lights and motor, etc. So we have not used any appliances here, but you can connect here on the side of this side and you can control those appliances. So we have also interfaced one display. This is an action display 3.2 inch, for displaying different parameters and environmental parameters like temperature, humidity, light conditions, soil moisture level, etc. It will get displayed locally here on this display. So you can see all assembly of this project. So this IoT hub or main controller hub, IoT hub, which has a Firebeetle to ESP32E development board. So we also receive the data broadcasted by these all sensor beacons, and then also we also send that data to cloud. So we have also used IoT Blink IoT cloud. You can see this application, Blink application, where we will send all this data via internet through router. So this module as this or this project all based on IoT, so it will get connected to the Internet of Things, and we will monitor all these parameters from anywhere in the world using this smartphone app, or you can also log into Blink Cloud IoT dashboard to monitor all these parameters and control different automations and all things. So this module, BLE Sensor Beacon module, it is powered by this type of cells, 3 volt CR2032 battery, coin cell battery. It will get inserted here in battery socket. So we will now power on all these sensor beacons. You can see all this. We will insert those batteries into that sensor beacons. So they will collect data from light sensor, temperature sensor, humidity sensor, and smoke sensor, and broadcast it over BLE to the main IoT hub, or it will broadcast around. And this IoT hub, Firebeetle to ESP32 microcontroller, will receive those packets, BLE broadcasted packet, and then will convert it to different it will show here on display and send it over cloud. So let me insert all those batteries. I will just pause here to insert the battery. Okay, now you can see I have installed all the batteries here. You can see we have inserted these batteries into the battery sockets, coin cell batteries, for all 4 sensor beacons. Now this sensor beacon will get powered on and collect data from sensors and broadcast it over BLE. So these beacons, how you can so once these beacons get powered on, it will start broadcasting. But how we can identify that all beacons are sending or broadcasting data? For that, let's use the app. We have seen these details about this app in our last article or video. This is a nano beacon scanner app. We'll scan all the beacons here. So just click on this play button. Okay, you can see all beacons will get appear. Okay. Now there are 3 beacons got appeared. Like first is, you can see here, smoke beacon, BLE smoke beacon. Second one is the BLE soil moisture beacon. Third one is a BLE light beacon, and the fourth one is a SHT40. So you can see all 4 beacons are now broadcasting the data. You can see the data here. If you click on this, you can see here all the details. So we have seen all these details in our last article and details, or you can also refer DF Robots wiki page of this sensor beacon module. You will get all the information about what is the manufacturer ID, what is manufacturer data, all these things. So this is a manufacturer specific data for smoke, soil moisture, Bluetooth, BLE light beacon, and this is SHT40 temperature and humidity sensor. So this is a temperature and humidity data, the manufacturer data. So in this way you can identify or confirm that all these four beacons, temperature, SHT40 temperature humidity sensor beacon, soil moisture beacon, and this analog smoke gas sensor beacon and ambient light sensor beacon, all these BLE sensor beacons are broadcasting the sensor data over BLE, and we can see those here. So now this IoT hub or microcontroller development board, 5-bit L2 ESP32E, as I said earlier, it has a capability of Bluetooth LE BLE reception. So we have programmed this to receive all these packets from all these sensor beacons, convert it, and then we have also programmed for different automations like turning on cooler for temperature rises, etc., and also for any smoke alert or buzzer will get on. All this sensor data will displayed on this next-gen display. And also on Blink app we will see different readings. So now it is offline right now because we have not powered on this main controller hub. So now let me power on this. Okay, you can see we are getting readings here right now, like temperature, humidity, ambient light, soil or and moisture. There is no smoke because we are not, there is no smoke in this room, so it is saying no. Soil moisture is showing 0 because the sensor is out of it is in a dry condition, you can see. So this is a wet soil. We will place this sensor in this wet soil. We will get some readings here. For ambient light, it is because I am recording in a night, so it is showing 0%. We'll flash some light on this sensor, then we will get some readings here for ambient light. Now let's see here in app, you will see same readings. Alright, so you can see the temperature and humidity readings. That is, temperature is 29.55, 54, and humidity is 33.37. So it will show same will show here, you can see 29.54 and 33.37. so similar readings you will get here. So light sensor is not showing any readings because I'm recording it in night, and this ambient light is not getting detected by this. It is detecting dark here. So I will just turn on the flash of this. Let me see. You can see here in light sensor. Okay, now you can see the light. So I'm alright. So you can see this is now it's light is getting ready. I am focusing my flashlight on light sensor, so you can see that. Now you can see the light reading also on blink app. Now we will see the soil moisture reading. Okay, soil moisture reading is 0 because we have placed the sensor in dry. Now this is the wet soil. I will place this sensor in the soil and we will get some readings. So let's place this. Okay, you can see now soil moisture is populated there and also here in a blink app. So likewise this will get work. Now there is some edge level automation we have programmed. So when temperature goes above 30 degree, the cooler will get on. Let me put some heat on this sensor, temperature and humidity sensor. Just see the relay, it will get turned on for cooler. Now see, temperature is above 30 degree, now relay get turned off. Now again I will show how it will work. Likewise we have also programmed different automation. You can check out that in code. So this is the demo of this project. You can get all the schematics and code on our repository of this project. So we have also programmed some automations or added some automations in here in a Blink IoT cloud app. So here you can add automation. Let me show you. So you can add here automations. Here we have added two automation, which is one is a smoke alert, another is a plant water alert. So for smoke alert, you can see when smoke is on, right, this automation will get triggered. Let me show you. Here now smoke is there is no smoke here. Okay, so you can see here sensor, which is a analog smoke or gas sensor. There is no smoke. When there is a smoke, it will trigger this automation and we will get pop-up notification on our app about smoke alert. So likewise here you can see there is another automation, which is plant water. So you can see in this automation, when soil moisture sensor is lower than 40%, we'll get this alert, plant water. Alright, so now you can see the soil moisture is 62% because the soil moisture is already in wet soil, so that's why it is showing 62%. The temperature automation is here working right now. You can see the relay is on, the cooler relay is on, because temperature is above 30 degrees Celsius. Okay, now we were talking about soil moisture. Here 62%. So you can see here we can set this automation. Now both automation are turned on. Now let's see the demo of these automations, how we can get notification about soil moisture and smoke alert. First we will see about soil moisture. Now the level is, you can see, 62% soil moisture here. Now we will remove the sensor from wet soil and it will get dry, and the soil moisture will get below 40%, and we will get notification here on app. So let's do that. Let me remove that sensor here. Now I have removed the sensor here. You can see I have removed the sensor. Okay, now we got, you can see, pop-up notification. So let me show you that notification. Alright, this one, the plant need water, soil moisture is below 40%. So this was about soil moisture notification. Now let's see about smoke notification. Not down, there is no smoke now. Now I will put some smoke here. Okay, so I will put some smoke here. So here is the smoke sensor. You can see smoke alert is there. Let me show you that alert. You can see here LED is red here. And it is showing here smoke is S. Okay, now it got removed. Let me show you the notification. So here is the notification of smoke alert. So likewise this sensor of smoke work. So this is all about working of this project. Thank you.